Hello, you're listening to Wine Blast with me, Susie Barry, and my husband and fellow Master of Wine, Peter Richards. And in this episode, we're going to dive headfirst into a glass of wine and wallow around a bit. No change from normal there, you might say, but no, this is proper work, proper research, because we are going to uncover the astonishing reality of just how complex and fascinating the chemistry of wine is.
The very finest kind of complex chemical soup, which, as will become clear, is still something of a wonderful mystery. Talking of which, in this show, we're going to touch on everything from flowers to cigarettes, farting, petrol, AI, whisky, urine, and strawberry-flavoured yoghurt. Here's a taster of what's coming up.
We should not just look at chemical compounds and think about the impact of this compound on its own. It's more of our job to just enjoy what it is in the glass as a whole complex matrix. AI can certainly not do that yet.
Gus Zhu there, the first Chinese master of wine who works in the US as a wine chemist and sensory scientist. Gus has just published a brilliant book called Behind the Glass, The Chemical and Sensorial Terroir of Wine Tasting. We'll have a discount code for that at the end of the show. Gus says, and I quote, "Behind every glass of wine there is science." But note, in that snippet you've just heard, how he also talks about enjoyment. So Gus is going to be our genial, white-coated guide to this intriguing world of flavour chemistry. There may even be a little experiment along the way.
Ooh, I love the sound of that. Can we blow stuff up, please?
No explosion.
Obviously, the best bits of chemistry at school were sort of blowing stuff up, weren't they? I'm not sure how we can shoehorn blowing stuff up into wine experiments, but I'm going to
try. I'm going to live in hope.
I'm going to live in hope on that one. Pop. Anyway, the reason we're doing this episode is we had a listener question in from Ellen Pranter, who's from Sweden, who writes as follows. Hi guys, thank you so much for one of the best podcasts ever. You go in depth, but in a fun and easy way. Love it. Now, I love wine, and I can't stop asking the question, why? When starting to learn about wine, I was told that Cabernet Sauvignon smells of blackcurrant. My first question then became, why does the Cabernet family of grapes have the aroma of blackcurrant? What compounds come from the grape, which are created during different stages of winemaking? I would love to hear you talk more about wine chemistry in your nerdy but easy and understandable way. I find it fascinating where in the process the famous aromas of some styles of wine occur and the chemistry behind it.
Nerdy but understandable. I think that's a compliment.
We'll take it as a compliment. Let's just take it as a compliment.
But no, I mean, what a great question. Thank you, Ellen. We did touch a bit on chemistry in our recent episode on wine faults. And we also did an episode back in season 3 on the magical science of taste. But this is a bit different. As Gus says, there is science behind every glass of wine. And this is a great excuse to explore that a bit more.
What Gus also says, literally on page 1 of his book, is that he's often asked to explain the science behind why a wine tastes the way it does. And he says, there's no short answer. First, he points out that chemically, wine is one of the most complex solutions in the world. And secondly, not only are human senses among the least understood subjects in the scientific world, but we're all different. So the same glass of wine can be perceived in very different ways by different people. He writes, it turns the seemingly simple question, why does it taste that way, into a surprisingly complex one.
Okay, so we've got our complexity and subjectivity disclaimers out of the way early, but we do like answers on Wine Blast as much as questions, and Gus provides lots of those. Yeah. So that's going to give us plenty of good material to work with to answer Ellen's questions. Yeah. To summarise, though, there are two things going on here. The chemistry in the glass, which comes from grapes and microbes and winemaking and aging, etc., and then our personal interaction with the wine. Gus defines these as the chemical terroir of a wine, i.e. what's in the glass, as distinct from the sensorial terroir, essentially what we make of that chemistry.
Yeah, so we'll explain and explore this a bit more in due course, in case your head is already starting to spin. But these are really important distinctions to make from the outset to frame our discussion, if you like. Now, Gus's book itself is structured around the human senses, starting off with sight, i.e., how wine looks, and then moving on to taste. So that's where we started too. I asked Gus how he would describe a glass of red wine to me analytically in terms of chemical components.
So the color we can see in red are from anthocyanins, and that's very chemical and people might find it boring. But once I link that to real life situations, like almost all flowers we see in the field of fruits, when they are red or purplish in color, they are coming from anthocyanins. So again, we can see that, right? So I say anthocyanins. Maybe some people may feel it's a bit complicated, but actually you can connect it into your daily life. And then tannins are those astringent compounds we can perceive in the red wine. And if you don't know tannins, drink tea, and teas are filled with full of tannins, or eat raw bananas, right? You can feel that astringent, drying mouthfeel.
And why? So let's say, to get more complicated, why are those compounds there? Why are flowers red? Why are red grapes red in terms of colour? And then why do they have these tannins that we can perceive in our mouths as well?
Yeah, it's a bit complicated, but in general, it's more about how those flowers and fruits serve their main functionality, which is reproduction. So to pass down the genetics to survive in nature, they have certain colors, either to protect them or to let them be attractive to humans or animals to eat and help them spread seeds. And those are all about nature. So in my book, I really try to deliver one message is to appreciate nature and try to smell and eat and drink as many things as you can so that you can actually connect what's around you into a glass of wine.
So wine professionals aren't any more gifted than anyone else. They just paid more attention to the smells and the tastes around them and given them names, and then you can suddenly do it.
Exactly. And honestly, I found out that at least around me, those people who love to eat and drink all sorts of things, they tend to be better wine tasters.
So we have official scientific advice to smell and eat and drink as many things as we can. Happy days.
Pretty much.
But you can see exactly what he's saying. Wine captures so many things in one glass, all of which can be found in the natural world around us. And we can train ourselves to learn this language of taste and scent by repeated exposure.
Yeah, Gus does indeed compare it to learning a new language in his book, because it's difficult connecting words to smells and tastes and sensations, isn't it? Equally though, it's not impossible, and it's actually quite fun to learn too. Now, talking of fun, for me, it isn't real science if you can't do experiments. And Gus did suggest one in terms of colour.
Oh, does it involve explosions? Do I need to put my safety goggles on?
Oh, safety never takes a day off. I'm disappointed if you don't wear safety goggles, to be honest, permanently. You wear them so well. No, sadly, no explosions.
That is not a compliment.
Unless you're talking about explosions of colour, that is, because that's where we're going with this. Because Gus mentioned anthocyanins there, which is a group of compounds that belong to a large category called phenolics, which make wines more interesting, both in terms of chemistry and also taste.
Now, we've talked about this before on the pod, haven't we? We also mentioned it in our recent episode on the vines of the future.
Yeah, we did actually.
And this is a point that Gus makes in his book too, how all grapes historically are thought to have been dark coloured. So red or black, however you want to term it, probably to catch the eye of animals who might eat them and help distribute the seeds in their poo, thereby helping the vine reproduce and spread.
Yeah, and then white or paler skinned grape varieties are more recent mutations, right? The key difference being the specific anthocyanins in red grapes absorb other wavelengths of light but reflect the reddish wavelengths into our eyes, hence
unless we have issues with colour blindness.
But
that's a whole other discussion, which Gus does actually explore in his book, doesn't he?
He does, among many other things. So anyway, various things can influence a wine's colour. One is how acidic or not the wine is. In other words, its pH. So this is a good way to observe wine chemistry in action. So if you grab a glass of red wine, if you slowly add tap water, hence lessening the acidity or raising the pH, the colour in the wine, if you look carefully, will change from more red to more blue-purple. In theory, if you then add something acid back in, like lemon juice, for example, and lower the pH in doing so, the colour should revert back to more red. So, I'm seeing a virtual disco ball in my wine glass right there. Boom.
What is it with you and disco balls? But this difference in colour is due to different forms of anthocyanins being present at different pH levels, right?
Yeah, exactly.
So a visual representation of the chemistry in the glass. I mean, it's the same with flowers, isn't it? Gus talks about a Brazilian flower that can change colour from purple to lavender to white in just a few days because the plant changes the pH, which influences the colour of the anthocyanins.
Yeah, that's right. And as humans, we're primarily visual creatures, so this kind of thing is important. But we also mentioned taste there. Gus touched on tannins in red wine. Now, our palate is the last checkpoint for toxicity when it comes to food, so our tongue and mouth are crucial to our survival. But, I think we often underestimate its powers and potential.
No, I agree. Yeah. And in the book, Gus does a great job of giving an up-to-date understanding of human palate perception. And that understanding has changed a fair bit over the years and probably hopefully will in the future. For example, that old chestnut of the tongue map where tastes are supposedly sensed on different parts of the tongue. So sweet at the front, bitter at the back, sour and salty at the sides.
Yeah, I remember that.
That has absolutely been proven to be false.
Yeah.
Our tongue has loads of papillae all over its surface, which house our taste buds, which can in turn detect all the different tastes.
So each taste bud can detect all the different...
Exactly, and it's all over.
Yeah.
So not just... And it's not just the basic, 5 of salt, sweet, sour, bitter, umami, probably more too. Fat, for example.
Yeah. And bitterness, which you mentioned, can indicate poison, for example. But, I find it interesting because, we can tolerate a bit of it and can even learn to like it, for example, because it can make things taste more interesting, especially, as we get older. For example, like tannins in wine, that's how we can get a taste for those.
But then personal perception of bitterness is one of the things that can vary most between people. For so-called hypertasters, bitterness can be almost painfully disgusting.
That's where you sort of very sensitive.
Yeah, so sensitive. But then for hypotasters, as opposed to hypertasters, the same level of bitterness in a food or tannin in a wine is absolutely fine. Apparently, women tend to be more sensitive towards bitterness and sour and salty tastes than men. And then young people are generally more sensitive than older people.
You're trying to tell me men are just not very sensitive people?
Old men. Old men that can take as much bitterness as they need.
That's a lot of bitterness
that you can throw at them.
Let's move on. But it's also interesting. Genetics can also influence the way you can taste in another really interesting way. For example, the composition and production or flow of saliva varies significantly between people. Now, this can affect the perception of tannin. Tannins produce a drying and astringent sensation because they reduce or remove the lubricating functionality of saliva proteins. So if you have more saliva, it's likely the wine will taste less tannic.
And it's the same with the perception of saltiness too, isn't it? Our saliva is naturally slightly salty, or it contains sodium ions. If something tastes salty, it's because it has a higher concentration of sodium ions than what's in our saliva. But if your saliva naturally, or at that moment in time, has a higher sodium ion concentration than mine, then we'll perceive that level of saltiness very differently.
This is getting a bit weird.
It is a bit.
I mean, I know we're married.
Weird, complicated.
But, even then, discussing the saltiness
your saliva and my saliva.
Your saliva versus mine is...
So
I don't know. I just think it's dangerous territory. I just think it's dangerous territory. Even if it is interesting in terms of the perception of salinity in wine, I say let's move on. Do you think?
I think move on.
Okay,
move on.
So there we go.
From spit
to my mind, it's the bits about aroma in Gus's book that I find most interesting, and I think that's what Ellen was driving at in her question too. Gus says that theoretically, we humans can detect 1 trillion different smells, but it's not certain. Plus, anyway, our olfactory vocabulary is limited. Certainly don't have a trillion words for aromas, do you?
No.
I get stuck after about 12.
Blackcurrant, isn't it?
So, so what are these smells in wine and how do we interact with them? I asked Gus how many aroma compounds there are in a glass of wine.
That's very interesting because if you ask the flavor chemist, they may tell you that at the moment, we might have found out probably hundreds of aroma compounds already in wine. But in my opinion, there could be thousands or even more. What's interesting is that, for example, I analyze TCA, which is a compound that causes cork taint, right? In cork or in wine or in other products. But those compounds, they are at parts per trillion level, meaning that if you have, let's say, 2 units in a trillion, in that kind of concentration, we can smell them, meaning there could be compounds like TCA that is extremely low in concentration, but they have a huge sensory impact. And we actually will see more and more of those kind of compounds being discovered by scientists, I believe, over the next 5, 10, or 20 years.
So the truth is, we really don't know how many aroma compounds there are in a glass of wine right now.
Especially the small ones, but yet they have huge sensory impact.
Fascinating. Okay, so let's get down to basics. I've got a glass of peppery Syrah in front of me. Doesn't matter where it's from. Talk me through that in terms of the chemistry of those typical aromas that we're going to find in that glass.
Okay, so for the fruity aromas, we might save that for later because there's a huge group of them. But for the peppery notes, it belongs to a big group of compounds that we find in nature. As always, they are called terpenoids, and some wine industry people call them terpenes, which is actually a smaller subgroup of terpenoids. But if you say terpenoids or terpenes, however you say it, we understand, right? And those terpenes, I tell you, it has probably hundreds of different expressions. Cigarettes, they are filled with terpenes. And hops in beer, they are filled with terpenes. And wine, of course, we have lots of wines that have lots of terpenes, like muscat grape. Those kind of floral aromas from muscat, they are terpenoids. So for Syrah, the peppery notes is one type of terpenoid. Just to think about how diverse the terpene or terpenoid world is.
So just to interject here, we should firstly explain that Gus's current day job involves him studying TCA, the compound behind cork taint, hence that connection. But in terms of the discussion here, Gus is talking about rotundone, right? In terms of the peppery character in Syrah, like you find in Côte Rôtie or Hermitage in France, or Swartland in South Africa, or San Antonio in Chile.
Yeah, exactly. Now, rotundone is a terpenoid that gives the black pepper aroma. Now, interestingly, this chemical compound was only recognised as the active aroma contributor in actual peppercorns as a result of Australian researchers identifying it in their Shiraz.
Love it.
Isn't that nice?
Love it.
A good example of wine leading the way, as it does in so many fields, but in particular flavour chemistry there. But terpenoids are hugely diverse, as Gus says. So I asked him what other examples of terpenoids might we commonly come across in wine.
Yeah, I laughed because there's another smell that people always talk about that's interesting, but they are terpenoids. That's the petrol smell in Riesling. And the petrol smell in Riesling, they are terpenoids. What's interesting is that if you think about it from a chemical perspective, it's fascinating to connect the origins of them. So terpenoids are actually not complex chemicals. They are just carbon units, right? We have carbons everywhere. All the organic life, they are carbon-based. So plants or even some animals, they use carbons to produce some aromas to attract people or to make people think they smell weird, like Riesling or petrol in Riesling. But if they're carbons, right, they could be floral, but for the petrol smell in Riesling, I can sort of see why people connect it to petrol, because nowadays people actually use terpenoids to make biofuels. So if you think about all carbon coming together, they are petroleum, they are oils. It's just with certain structure of the chemical compounds, they could smell either like petrol or all the way to floral.
Okay, so these terpenoids, they vary. They're primarily coming from the raw material, the grapes in this sense. Is that right? And also, how do they vary beyond just the raw material? How can they vary maybe in the same grape like Riesling in different places?
Yes, so just pay attention to nature. As soon as you get into a garden or forest or anything, just go outside, smell all sorts of aromas. Chances are, I dare say 50% of them that you can smell floral, woody, or something like that. They could be terpenoids. And they vary, and sometimes they can change as well. There are certain compounds, like people try to find out how they change, right? They found out that certain floral terpenoids can actually change to something minty or more herbal as wine ages, or as certain food like a certain beverage product or cheese or something ages. They just change in their aroma nature.
So therefore, they can change not just according to where they are, but according to once they're in a bottle, they can evolve into other characters.
Exactly. And that is why I personally think those wines who are too strongly floral or fruity at the beginning, they tend to have a less aging capacity. And those with those kind of terpenoids or some other compounds that's locked in the wine that needs to age or needs to breathe, they tend to have longer aging capacity because they were locked and reserved in the bottle, in the wine at the beginning, and later they slowly release.
Okay, so terpenoids cover a big range of aromas, including petrol in some Riesling, which is a terpenoid known as TDN. Yeah. Now, Gus writes in his book that they permeate every corner of nature and constitute a powerful language in the form of aromas. Different grape varieties have different constituent terpenoids, which make them smell different. And I understand from Gus's book that even the same grape variety will create different combinations of terpenoids due to environmental variations or terroir. So that's really intriguing.
Yeah. So a chemical justification for terroir. And then all that can then change in the bottle. As Gus said, for example, the floral scented terpenoid linalool, I hope I'm pronouncing that right.
Linalool,
like someone out of Star Wars.
Who knows?
Which is often found in muscat, can be converted to 1,8 cineol over time, which smells more like eucalyptus. So, there's more research to be done there. But essentially, yes, terpenoids are fascinating. They're about fruits using volatile aromas to chemically signal their maturity. So the concentration of beta-damascenone, which smells fruity and floral, can be a marker for grape maturity, for example.
But terpenoid smells aren't just about floral and fruity. They can also be spicy and petrol-y.
Yeah, absolutely.
Intriguing. Right. I think a quick break and a breath, and then we'll get back on it. By way of summary so far, wine chemistry is complex, human perception too, but we're starting to discover intriguing things about both, from how simple carbon compounds can make your Syrah smell of pepper or your Riesling smell of petrol, to how your perception of tannin can vary according to your saliva flow.
I thought we'd agreed never to talk about saliva again.
Just
ever
had to
again.
briefly mention it.
Anyway, okay, so we've discussed terpenoids, but now I wanted to hit Gus with Ellen's original question. Why does Cabernet Sauvignon smell like blackcurrant?
So that's a different group of compounds. And to be honest, we don't know the true nature yet of the so-called black fruit, especially blackcurrant. So far as I can tell from the literatures, from the scientific journals, a group of major compounds that contributing to the blackcurrant smell, they are thiols or sulfides. Those are sulfur-related compounds, not the sulfur as we do when we add sulfur dioxide into wine when we do winemaking, but those kind of natural occurring sulfur compounds either from the grape or mostly coming from the fermentation by the yeast. It's a byproduct of yeast that tend to generate those kind of black fruit smell either in Cabernet Sauvignon or in certain other red wines like Syrah or those kind of drinks.
How much of the character, let's say in a glass of Cabernet Sauvignon, is down to the raw materials from the grapes, and how much is down to the winemaking, the yeasts included in that process?
So if you ask a winemaker, they tend to tell you that most of the aromas were coming from fermentation or some other microbial activities like malolactic conversion by bacteria, right? That is true, but it's hard to say in terms of if you don't have certain things, what we call the precursors, existing in the grapes in the first place, the yeast will not have the materials to convert into the aromas later. So I think it's hard to say a percentage. It's more helpful to think in a way that they are both very significant. The raw materials as precursors of aromas in the grape, and how the yeast bacteria later convert those kind of raw materials into aroma compounds.
Okay, so that's interesting because you'd maybe assume that a blackcurrant aroma from Cabernet Sauvignon would be straightforward in terms of the compound and pathway. Yeah. But it seems that's not the case.
No,
we're talking precursor compounds in grapes that are then converted by yeast during fermentation into these volatile sulfur-containing compounds.
Yeah, and I do find these thiols or sulfur-containing compounds more broadly really fascinating. Gus explains how we humans have a love-hate relationship with sulfides. He cites the example of the durian fruit in his book, which is filled with sulfides and which some people adore and others find absolutely unbearably revolting. We're all sensitive to sulfides because they can be dangerous. Hydrogen sulfide, which smells of rotten eggs, can be toxic in excess, which is why we fart to get rid of it.
You did promise to get farting in here somewhere, didn't you?
I told you I was going to get farting. I don't always say that.
There we go.
I do try every episode.
There
actually,
it is.
But sometimes it's appropriate. There we go. Told you sulfides are fascinating. Now, apparently decomposing bodies also release hydrogen sulfide too. So again, it's a smell we're wary of. But our bodies do need sulfides in small amounts, so we learn to tolerate or even like them. So coffee, for example, is also full of thiols or sulfides, and we love coffee. So, that love-hate dynamic there.
And in wine, just to bring things back onto topic here, we're talking smells like blackcurrant in Cabernet Sauvignon, but also grapefruit in Sauvignon Blanc, and then struck match or fresh curry leaf in what's often termed a flinty or mineral or reductive style of Chardonnay, for example.
Yeah, absolutely. So the former, the Sauvignon Blanc sulfide, is 3-MH, and the latter is benzene methane thiol, for what it's worth, that mineral reductive struck match character. But actually, these sulfur compounds have a huge range of smells, and Gus reckons there are loads we still haven't discovered yet, which is intriguing. But we'll come back to this subject in a bit. Meantime, I ask Gus, if precursors in grapes are so important to the wine's final taste, how can you farm grapes to generate the best possible raw material for the wine?
Yeah, it all depends on the winemaker's own experience and taste and the grower's experience, because there are just so many things that's unpredictable during winemaking, right? You don't know how the yeast will convert certain precursors in the grape into aromas. But there are some markers that we can go for, and those markers tend to be those kind of aroma compounds that already exist in grape, and they are readily to be released, such as the terpenes we talk about, such as some other things like the green bell pepper smell from what we call the methoxypyrazines, right? They are there because nature in grapes or in other plants, in all green parts of plants, they produce those kind of green peppery green aromas just to repel those kind of herbivores or those kind of insects that might damage and eat the plant.
So let's talk about those methoxypyrazines for a moment. You've talked about them being sort of green smells that can maybe crop up in grapes like Cabernet Sauvignon or Sauvignon Blanc. How do they get, if they're meant to repel herbivores from eating the leaves, how do they get into the grapes and the wine?
So that's the interesting part, that we don't know why, but the truth is that grapes like Cabernet Sauvignon or the Cabernet family, including Merlot, including especially Cabernet, they somehow can let the pyrazines translocate or synthesize in the grape skins, or shall I say, it remains in the grape skins, because most of the grapes, as they ripen, those piercings went away, right? But those Cabernet Sauvignon, Cabernet grapes, they keep those kind of compounds in the grape skin. But my personal theory, this is not exactly 100% scientific. My personal theory is that Cabernet Sauvignon or Sauvignon Blanc or Cabernet, they tend to be more ancient varieties, and they tend to have better capability and potential of producing compounds that help them survive in the nature. If you think about it, the more ancient the grapes would be, like Muscat, like Pinot Noir, they tend to have more complex aroma compounds. And that is probably because throughout evolution, they generate this kind of capability of producing either attractive smells, like those kind of floral smell some people may get in Muscat, Pinot Noir, or some disgusting smells to insects, to herbivores, such as methoxy piercing, those kind of green notes, just to help them survive better.
But a little bit of that green note can actually work quite well in a wine. You say sort of Cabernet Sauvignon, that can be really quite nice.
Exactly. That's why I personally would say the Cabernet Sauvignon evolved in the way that served human beings' palate.
So the oldest grapes in evolutionary terms are the ones with the most complex aroma profile. That's really interesting and something I've never even considered.
Yeah, it's intriguing, isn't it? I agree. But just to go back to pyrazines specifically, which Gus mentioned, this is another part of the Cabernet Sauvignon aroma profile. To go further into Ellen's question, that green pepper or leafy or vegetal spectrum. And these compounds are nitrogen based and include things like IBMP, which smells like green bell pepper, and IPMP, which smells like peas or potatoes fresh from the earth.
Now, we had those in our faults episode, didn't we? Our wine faults. And we discussed there. Exactly. Yeah. And we discussed there that some people might find them objectionable, but for others, in not too high a concentration, they're fine. Exactly.
So we've touched on terpenoids, phthals or sulfur-containing compounds, and pyrazines, but there's another major group of aromas we need to cover. I asked Gus to give me an example or two of a wine style that's influenced by the yeast from winemaking.
So there are two folds. One is that for most of the fruity smell, we talk about terpenoids, terpenes, but there's another major group of smell, and those are called esters. And esters are mostly fruity, such as if you smell banana has lots of esters, right? So those kind of fruity smell that can remind you of certain fruit, they are esters. And why they are mostly made by the yeast? Because esters were made by putting two things together. One is a type of acid, any acid. The other is a type of alcohol. Okay, so you put acid and alcohol together, the yeast will put them together, and then you get a compound called esters. And for most of the flavoring industry nowadays, such as the flavor or aromas of soap or any type of food like yogurt, strawberry-flavored yogurt, or those kind of things, they were all made by adding esters that's now synthesized by yeast or just chemical engineering.
So, and they are alcohols plus acids. So you need that fermentation to be happening for them to be produced in the first place.
Yes. So within the body of yeast, when they metabolize during the fermentation, they started to create some intermediate alcohols and acids, and they tend to put some of them together to generate those kind of esters.
Our old friend Esther.
She is.
Now we're talking fresh fruity flavours with esters, right? I'm thinking aromas like apple, pear, peach, banana, strawberry, that kind of thing, which are typically found in young fruity wines like Beaujolais Nouveau, which people often describe as tasting like bananas or strawberries.
Yeah, absolutely. As Gus says, they're made by yeast acting on acids and alcohols. So isoamyl acetate is made from isoamyl alcohol and acetic acid, and it gives that banana smell we're talking about. But over time, wine's acidic nature often encourages esters to break back down into their constituent parts, a process called hydrolysis, meaning these fresh fruity aromas can reduce in bottle. Makes sense, right? Older wine smells less fresh and fruity than a younger one. It's also a question of balance. For example, ethyl acetate in moderation can smell just generically nicely fruity. In excess, it can smell like nail polish remover. So, that's an ester too.
Yeah. I also read in Gus's book that it's the precise combination of esters that makes us think of certain fruits, not specific ester compounds. What makes it more complicated is that even with the same concentration, a certain ester can give different aromas when a liquid has a different chemical makeup. Yeah. So in short, it's hard to predict what fruit aromas a wine is going to have based just on chemical data. It is a symphony, not a solo act.
Love that. Symphony, not a solo act. And all orchestrated by our friends, the yeasts.
The conductors.
Here. Exactly. Now, we should also remember other ways in which those wonderful microbes called yeasts can affect a wine's flavour. The famous flavour of Pinot sherry is largely down to the floor yeast that sits on the wine surface in the Syrah barrels. When it comes to long-aged, traditional methods sparkling wine, the dead yeast cells imbue the wine with flavour and texture. And let's not forget the sulphur-containing compounds we touched on earlier called sulfides or thiols. And I wanted to use this as a way to explore the idea of sensorial terroir or personal experience with Gus.
People really have different sensitivities, especially towards sulfur-containing compounds. Why? Because they could be toxic, because if you smell too much of the hydrogen sulfide, you will get intoxicated. But we also need them. We just need a small percentage of them. Why? Because those compounds can also be compounds that help with communication between cells. So within our body, the sulfur-containing compounds are actually messengers that help communicate those kind of functions. So it's a weird type of compound that we may hate it, but we may also love it depending on the concentration, also depending on your own genetics. One example I always say is if people realize a thing called the asparagus pea or coffee pea, they will understand this, because after eating asparagus and drinking coffee, as we metabolize in our pee, in our urine, we will have those kind of compounds. But some people, especially, I don't know why, but it's probably just genetic, that in China, when I ask students or ask a group of audience about asparagus urine, and they are never aware of it. They never realize that kind of smell. But to most people I see in UK and here where I'm now in America, most people can smell that. Meaning probably in certain population, like in Caucasians versus Asians, Caucasians have the genetics that are more sensitive to those kind of smells.
So we vary in terms of genetics, we vary in terms of personal preferences, we also vary between cultures when we can all be assessing the same wine, but we could be tasting and smelling something completely different.
Very different, such as we mentioned champagne or certain sparkling wine, right? That's not necessarily aromas, but when we put those kind of traditional method sparkling wines in our palate, okay, when we actually taste in the mouth, I tend to find that it's harder for me to explain what is the umami taste contributed by the yeast autolysis in those kind of sparkling wines towards at least American audiences. Versus in China, if I explain them to people, they say, oh, of course, I can also taste that kind of savory umaminess coming out from the so-called yeast autolysis.
That's really interesting. Can you, well, since we're on the subject, can you talk to us a little bit about the flavors, the chemistry in a traditional methods, maybe older vintage sparkling wine, like an older champagne?
Yes, so of course there are certain fruity smell, as I mentioned, coming from the grape, and also those kind of esters, fruitiness coming from yeast. That's the primary fermentation, right? But once you get into the second fermentation in the bottle and you start to age the wine with the yeast for a long, long, long time, they start to release the most complex compounds. They are dead yeast cells that start to, why it's called autolysis? Because they start to automatically break down they start to release all the things from within their body. So what you're essentially looking at is that all sorts of compounds from proteins, amino acids to all the unpredictable components that scientists yet need to discover more. And that is nothing less complex than a glass of milk, because it's all those kind of compounds that are coming from an organic life's body, the dead yeast cells.
So yeast contributes flavour when it's alive and also when it's dead. They are heroic little critters, aren't they?
My heroes.
And we do have a lot to thank them for in terms of flavour chemistry or even just deliciousness.
So much to be grateful for. Now, to finish off, I asked Gus about the bigger picture. He took an example from his own research into TCA, the cork taint compound, which, as we know, even in tiny amounts can ruin even the most expensive bottle of wine. But he then tested it out on a different matrix.
What I also found interesting is that those compounds in different drinks, in different matrix, they tend to have different sensory impacts. For example, I use the same group of people, including myself, to smell the same amount of TCA in a wine versus in a glass of whiskey. And in the whiskey, they are not that obvious. Probably because the high ethanol, high alcohol content kind of mask the TCA smell in whiskey. And it didn't destroy much of the desirable smells, other aromas in whiskey either. So I found it fascinating.
Because you make the point in the book about other compounds in higher alcohol drinks being actually much, much worse.
Yes, so it really depends on the matrix. So what I try to tell people in the book is not only about the chemistry side, it's also about we should not just look at a chemical compounds and think about the impact of this compound on its own. It's just a guidance that help us think, right? But it's more of our job or our own mission to just enjoy what it is in a glass as a whole complex matrix.
Because the wine is complex and we're complex.
Yes.
How much do we really understand about how the interaction of this sort of complex chemical soup results in any given wine's character?
Very little, especially on the sensory side. And that is why my main research direction is sensory studies. It's not about I study one component and I study certain genetics and I can predict what will happen. It's more about, hey, there's a product over here, whether it's a perfume or it's a wine. And then I see a group of people or a large group of people interacting with the product and see their variabilities. But also among those kind of variabilities, can we see some patterns that makes it more commercially significant for the winemaking world? Such as, again, let's talk about Marlborough Sauvignon Blanc. Why it became successful? Because they do have that type of component in the wine that can only be made by modern winemaking techniques, such as certain yeast and anaerobic protective winemaking, stainless steel tank, temperature control, all that, and just hit the sweet spot of human beings. So we need to just test our product, not only by machines, but also using humans as machines, using human nose, human palate to test them. And that's what sensory study is about, is that there's nothing you can predict in advance. AI can certainly not do that yet, It's more about you have these kind of recipe and you let people taste it and test it and see if they can make more sense commercially. And companies like Coca-Cola, Pepsi, and all these kind of companies, they do tons of sensory studies just to use human beings to verify.
Fascinating. So wine has a sort of enchanting magic to it of itself, but also there's a profoundly human interaction to make it all come to life and make it make sense.
Exactly.
Gus, thank you very much indeed.
Thank you, Peter.
So it's reassuring to hear we humans still have a part to play. And I like the idea that as much as we try to simplify or reduce wine to its chemical basics, it still resists easy categorization and evaluation. It's complicated. We're complicated. And sometimes we should just enjoy it for what it is.
Yeah, a whole complex matrix, as Gus says, or in other words, a nice drink. We're going to wrap things up there. Ellen, I hope we've done your question some sort of justice. I fear we've only just scratched the surface of what is a hugely complex and intriguing realm. But I'm sure we'll come back to this topic from another angle in due course. And in the meantime, for those who want to know more, we'd recommend Gus's book highly.
On which note, we have a 15% discount code for you, which apparently is currency agnostic. I do like that notion.
Wish I could be currency agnostic.
So this code can work globally, and I think the publishers ship to most places as well. The code is WineBlast15, WineBlast 15. The book is called Behind the Glass by Gus Zhu, MW. You can order it from academyduvinlibrary.com, and we definitely suggest you do if you found this programme has piqued your interest and you want to know a bit more. It's not expensive and it's fascinating stuff. Really well written and highly engaging.
Yeah, there are bits on tears, bubbles, legs, specific anosmia. I mean, I could go on. Yeah, I'm not sure.
He doesn't stoop quite that low.
I think that was me. I think that was my only addition.
It's all yours.
It's a red flag, isn't it? Oh dear. Anyway, there is all sorts of interesting stuff in there that we haven't had time to cover here. And there's a lovely bit at the end of the book as well where he puts 6 contrasting pairs of wines together to illustrate all his key theoretical points in the book. So you can literally put all the theory into practice, just get these wines and taste them. It's really fun. We definitely recommend you do that because it really brings it to life. And you can call it research.
Which is how we justify our entire career, isn't it? So by way of closing summary, wine is one of the most gloriously complex liquids on the planet from a chemical perspective. It has hundreds, if not thousands, of aromatic compounds, from terpenoids to sulfides, pyrazines to esters and beyond. Its appearance and taste and aging potential are all determined by a complex string of chemical interactions, not least of which is wine's interface with us, tasters, whose human senses can be just as complex as the wine. One day we might understand every last chemical nuance, but in the meantime, we can still enjoy the symphony without dissecting the score.
Amen to that. We didn't get any explosions in the end, did we?
No.
But hey,
No.
that's life.
Too
Maybe
bad.
next time. Our thanks to Gus Zhu and Académie du Vin Library. And of course, thanks also to you for listening. Until next time, cheers.